Good morning, class. In our last class, we have started the chapter periodic table and we have gone through the important terms related to it. So, in the periodic table, we came to know what are groups, what are periods, how many groups and how many periods are there in a modern periodic table. And after that, we discuss about important groups like group 1, they are called alkali metals, group 2 alkaline earth metals, group 17 halogens, group 18 inert gases or noble gases, and we also came to know about the different types of elements: representative elements, transition elements, inert transition elements, novel gases, all this type. Okay, we discussed in the last class. Now today we are going to study about the topic known as periodic properties, or we also call as periodicity. Okay, first let us see what is periodicity or periodic properties. So the properties of elements which are directly or indirectly related to their electronic configurations and so a regular gradation as we move across a period from left to right or down the group from top to bottom are called periodic properties. So basically periodic properties means the properties that reappear at regular intervals. So after when you are moving across a period, that is from left to right in a periodic table, then after certain elements the element that you get will have a same properties. Okay, that we call periodicity. So the properties that reappear at regular intervals or in which there is a gradual variation, either increase or decrease at regular intervals, are called periodic properties, and the phenomenon is known as periodicity of elements. That is the definition of periodic properties. Now we'll see what are the important periodic properties. So the important okay, one more thing. Now, what is the cause of this periodicity? Okay, what is the main cause? So the main cause of periodicity is the reoccurrence of similar electronic configuration, that is having same number of electrons in their outermost orbit. So the main cause of periodicity is the having similar electronic configuration. If the elements have got a similar electronic configuration, that means the electronic configuration is the number of arrangement of electrons in the orbit. So if it is same, then they will have a similar properties. In a particular group, elements in a particular group, electrons in the outermost orbit remain the same. Okay, so say for example, if you go for group 1, in group 1 we have got only one electron in the outermost. All the elements have got only one electron. That is, electronic configuration is similar. Since chemical properties of elements depend upon the number of electrons in the outermost cell, thus elements of the same group have similar properties. And since the chemical properties depends on the number of electrons in the outermost orbit or cell, then the same group have got the similar properties, we can see. Okay, now we'll discuss about the important periodic properties. So these are the 6 important periodic properties that we need to discuss. Atomic size, also we call atomic radius; annihilation potential, also known as annihilation energy; electron affinity; electronegativity; metallic character; non-metallic character. So these are the 6 important periodic properties that we need to discuss. So first we'll discuss about atomic size or atomic radius. Okay, now let us try to understand what does this means, atomic size or atomic radius. So it is the distance between the center of the nucleus of an atom and its outermost cell. Okay, so atomic size or radius means, if you consider this as an atom, at the center we know that we have got a nucleus. Now, from the center of an atom to the last outermost orbit. Suppose if you consider this last outermost orbit, now whatever distance is there from the nucleus to the last orbit, that we call atomic size or atomic radius. And this atomic size depends on number of cells and nuclear charge. Number of cells and nuclear charge. Now we'll see its trends. Trends means variations. How the elements will have the atomic size when you move from top to bottom, that is down a group we called. Okay, and how the atomic size will vary when you move from left to right in a periodic table, that is across a period. So this thing is very important. Now we'll see down a group, what will happen. So down a group, the size of an atom increases. Okay, so when you move down a group, the size of an atom increases as we move from top to bottom. This is due to successive addition of cells, which overrides the increased nuclear charge as one moves from top to bottom. So when you move down a group, there is an increase in the atomic size, and this happens due to the successive addition of cells or orbits. Say for example, we have taken over here group 1 elements, which are known as alkali metals as well: hydrogen, lithium, sodium, potassium, rubidium and cesium. Okay, now when you move down the group, okay, the atomic size increases. Hydrogen will have a smaller size, lithium somewhat bigger, sodium bigger, and the last one will have the biggest one. Okay, and this happens why? Due to the increase in the number of cells. So when you write down the electronic configuration of each hydrogen, we write only K1. That means we have got only one cell, and there we have got only one electron. When you go for lithium, we write it as K2L1. So here we have got two cells. In sodium we have got K2L8M1, three cells. So if you go down the group, the number of cells are constantly increasing, and that will lead to the increase in their atomic size. This is how it varies down a group. Fine. Next we'll see across a period. What will happen across a period? That means when you move from left to right in a periodic table. So in a period, the size of an atom decreases. Now when you move from left to right in a periodic table, the size of the atom decreases. This is because the nuclear charge, that is the atomic number, increases from left to right in the same period, thereby bringing the outermost cell closer to the nucleus and decreasing the size of the atom. So what will happen when you move from left to right? The atomic number is increasing, but the number of cells remains the same. The only change is that the electrons are getting added in each elements or in each atom. So that will bring the nucleus and the outermost cell closer, and therefore it decreases the size of the atom. Say for example, we'll try to understand with example in a second period. Okay, in the second period we have got these elements: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Okay, now when you move from this left to right, the atomic size decreases. That means this will have a bigger size and this will be a smallest one. Okay, therefore in the second period it has been found that lithium Li has the largest atomic size, while fluorine F has the smallest. As I explained, what is the reason. Now assignment for today, assignment number 2. Question number 1, define periodic properties. Question number 2, name the important periodic properties. Question number 3, what is atomic size? On what factors does the atomic size depends? Question number 4, write the trends and regions for change of atomic size in the following: down a group, across a period. So complete this assignment and send it in my mail.